Okay, so we're going to learn the definition of a derivative. Basically, the definition of a derivative can be split into two different definitions. Overall, it's just the slope of a secant, so slope of secant. However, we have two different kinds of slopes at secants or derivatives. We have the derivative of a function and the derivative of a function at a point, basically at point. Okay, these have two completely different equations. However, they're both the slope of secant. So for a function, we have the limit as delta x approaches 0 equals f of x plus delta x minus f of x all over delta x. And for the tangent at a point, so the slope of the secant at a point, we have limit as x approaches c of f of c, or f of x, f of x minus f of c all over x minus c. Okay, now I'm going to work out a problem for finding the derivative of a function. I'm going to use the example f of x equals x plus 2. So basically, we're going to treat this as f of x, and for the first step, we're going to have to write the equation, or the definition, all over again, or else some major points will be taken off. Limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, exactly what we did up here. And then the next step, we're going to write it with our actual function. So limit as delta x approaches 0 of x plus delta x plus 2. So basically, instead of just writing x, we're going to have to add the delta x. So we have this, we're going to put that in a bracket, minus f of x. F of x equals x plus 2. And don't forget, all over delta x. Now we have this, and it looks complicated, but all we have to do is solve it. This is just algebra from here. So what we're going to do is rewrite limit as delta x approaches 0. We're just going to keep x plus delta x plus 2 minus x plus 2 all over, oh wait, this is supposed to be minus, so sorry about that, all over delta x, because we have to distribute this negative sign out to both values. Okay, so we see here that we can cancel a few things out. We're going to cancel out the negative 2 with the positive 2, the negative x with the positive x. What we have left is limit as delta x approaches 0 of delta x over delta x. At this point, you can see that these just cancel out and you get 1. If you were to plug in the 0, however, you would just get 0 over 0. That wouldn't work. Then you have to do, that's why you have to do this whole process. And you can figure that out at the beginning, I believe. Okay, so that's how we solve that. Now we're moving on to finding the derivative at a point. So for this one, I'm going to use a different example, a different function. For derivative at a point, aka at a point, you need a function and a point. So for this, I'm going to say f of x equals x squared minus 4. And I'm going to have my x equal -1. Okay, just draw a line here so we don't get confused. Okay, we're gonna do it basically like we did it the other way. We're gonna have to write the definition first. So limit, however, this time we're gonna have as x approaches c of f of x minus f of c all over x minus c. Now we're gonna start plugging things in. So we write limit as x approaches -1. Okay, you may be wondering why we put in the -1. That is because we have x equals -1, therefore c equals -1. So we have f of x, which is just x squared minus 4, that in a bracket, minus f of c. Now f of c is basically f of x. However, instead of having your x, we're going to plug in the c for x. So that means we have -1 squared, like this, -1 squared, minus 4. We know that this equals 1. So negative times negative equals positive. Then we have this all over x minus c, and c is -1. Okay, moving on. So limit as x approaches -1 of x squared minus 4, distribute this out, minus 1 plus 4 all over, this is plus and plus, just like algebra, x plus 1. Okay. Now we see that this cancels and this cancels. Nothing else cancels at this point because we have to do something we all love, which is factoring. So when we have this point, we just have x squared minus 1, just write that off to the side. So what does that equal? That just equals x plus 1, parentheses, x minus 1, all over what we have here, x plus 1. This is great because these two cancel. Makes our life easier. So we have limit as x approaches -1 of x, which we see here is -1, same as c, -1 minus 1. So that plus a negative equals -2. And that, my friends, my peers, and my students, is how you find the derivative, and basically the definition of a derivative. Thank you, and I'm signing off, Christine Johansen.